class for Dr. Zan. My name is Katelyn Roy.
My name is Rodolfo Falconi, and I hope Dr. Zan, you like this video. So we have this little model to be able to explain a little bit better Pascal's principle. This small model resembles a hydraulic machine. Pascal's principle states that when pressure is increased at any point within a confined liquid, then as a result, it's an equal increase in pressure within the whole container. Let's say the pressure that is exerted here, it's been transferred equally throughout this container, traveling through the tube into this other syringe, which allows us to lift any object on this platform. So to better explain Pascal's principle, we now have an example on the board. As you can see, this example resembles somehow the small model that we showed you earlier. This example requires us to find the force exerted on this piston in order to be able to lift the container on this other one. So, to be able to accomplish so, they are giving us the diameter, which is 2 meters, and the diameter 2 on this end, which is 5 meters, and the weight of the container, which is 10 newtons. Now, let's go ahead and remember what pressure equals to. Pressure equals force over area. So, if we go back and remember what Pascal's principle states, the pressure exerted throughout a confined liquid is going to be equal at all points, at every point. So we can say that pressure exerted on this end, let's call it 1, pressure 1 is going to be the same as the pressure over here, pressure 2. So if we say that, we can also say from this equation that force 1 over area 1 equals force 2 over area 2. Now, by having this relation, we can now find force 1, which is going to be equal to area 1 times force 2 divided by area 2. Now, since we have diameter 1 and diameter 2, we're able to go even further into more detail and substitute area 1 and area 2 using the diameter. So we come up with force 1 equals pi times diameter 1 squared divided by 4 times force 2, which force 2 would be the weight of the container, divided by area 2, which is pi times diameter 2, which we have right here, squared over 4. Now, since we have pi on the numerator and pi in the denominator, and then we also have 4 and 4 here, we can cancel those out, and we're going to end up having this final equation, which is force 1 equals weight times diameter 1 over diameter 2 squared. This equation is going to help us find the force on this piston to be able to lift up that container. So let's go ahead and do the calculations. They're already written up, so we're just going to travel through really fast. All right. So force 1 equals to the weight, which is 10 newtons, times diameter 1 over diameter 2, all this squared. So we come up with 10 newtons times 0.4 squared, which gives us 1.6 newtons. Now, as you can see, the force exerted here was a lot smaller than the weight of the container. And why is that? It's because the diameter is involved in this. And since our diameter is here, over here, is bigger than the diameter on this side, it allows us to require less of a force to be able to lift this container. This is how Pascal's principle is applied in our everyday life, and it helps us in so many different duties in factories, in refineries, supermarkets, and even when we have a flat tire.